Hey, it must be very, very, very near to 2 hours UTC because it is about time for Astronomy Daily Live. So, hey, everybody, you can call me Cosmic, and here we are again. This is a daily live stream about astronomy, all things astronomy, from, you know, whether you're a newbie or an amateur or a pro, you are welcome here, and glad you could come by. If you're watching this live or watching this in the future, uh, howdy. Hope everybody's doing okay. Hope your last 23 hours or so was nice and calm and fun. A little bit of fun. That's always nice. It's always nice. So hope everybody's doing well. The uh, the weather here has been clear and really nice. So I'm actually going to be going out tonight after this live stream to collect more image data. There's a couple of things that I I realized um, uh, last night that I need to either add or make a correction to. But maybe we'll hang here for a little while, see if we can get a nice little crowd into the circle, talking astronomy, just astronomy. Uh, but that entails a whole bunch of stuff, a whole bunch. Uh, you know, Scientists are hopefully, naturally curious about things. And when I was a kid, I was curious about everything, every single thing. I mean, the word I used more than any other word that I knew at the time, and yeah, to this day, I still sort of use that word quite a bit. Is the word why? Why? And you know, drives people crazy after a while. So what has to be done? What has to be done is you need to figure it out yourself. You need to figure it out yourself. You need to gather your resources together and find out things on your own. And oh, it's so much easier these days to do that kind of work. At least you can get, you know, uh, with access to the internet now, it's so much easier to sort of at least have a starting point, right? At least have a starting point. When 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 I was young and wanted to find out things, I had to go, I had to go to the library, the public library, and it was either a local one or um, maybe the city one. I started with a local one that was just a few blocks away, and it was actually a pretty nice um, library. I sort of wonder if it's still there because it's very nice. It sort of I think about it now, and it sort of reminds me of like those old bookstores, right? And how they smell. Yeah, the smell of old books is just fabulous. One of the first jobs I had when I went to the university was I worked for um, a part of the library called Special Collections, and it was exactly that. It was a collection of either very rare or um, sort of deemed important material that they had sort of a protective sense of. So it was reports and all that, but there were also some very interesting books, very interesting books. Uh, the I I remember holding in my hand a a copy. It was it was a copy made about at the time. Uh, later, of course, because it's a copy, but it was a copy of Galileo's book, and it was a copy of Newton's book. Basically printed at the time. It was like a second edition or third edition um, of these books, and one of them was actually a copy of Copernicus's book. So I held that in these hands uh, and read through it. Of course, all those books are written in Latin, so uh, wasn't really able to actually read much. But you know, again, you go back to just look at the pictures, and that's exactly what I did. And just looked at the diagrams, and just stood in absolute awe of uh, of what I was seeing at that time. So yeah, I don't know how I got off on that tangent. Oh yeah, getting back to libraries. So yeah, uh, back when I was a kid in like the 70s, uh, the the source of information was either the newspaper or at the library. And yeah, the first library I encountered when I was very, very young, and it was just a small one, just a small library, and but it had it had some astronomy books in it, maybe I don't know, a dozen or so. And when I found those, I absolutely consumed them. Don't even really remember what they were now. Doesn't really matter because I just, I don't know exactly how, but I stumbled upon this topic um, of astronomy, and being a curious kid, I uh, I latched onto it really really early because it seemed to me, and it still seems to me that um, that astronomy is the study of everything. Uh, so you know, you can sort of choose the the width and depth and and breadth of what you want to study, and it will last you a lifetime. It'll last you many, many lifetimes because there's just so much. There's so much. So I really like that whole idea of it being just this almost impossibly uh, uh, large piece of information that I'm trying to take some bites out of, and it was great. It was great, and to this day, it continues to be really, really great. So astronomy is sort of the study of the universe, and that goes from the very, very, very small to the very, very, very large. Goes all the way up, all scales, all spatial scales, and all temporal scales. So we astronomers like to look at things that move very, very fast, and might change uh, very, very often to things that uh, you can barely see change at all, um, or they happen so fast that yeah, so it's the study of everything, and of course I really like that. So yeah, I found all the books that I could at sort of the local library, which was barely any at all, but it was enough. It was enough, and for a 5 or 6 year old kid, it's like that's enough. That's enough. And so as I got older, a little bit more responsible, could be let out of the house, not attended for a couple hours or so. I discovered the main library, which was downtown, the big one, the one that had the most books in it that there were. And at this main library, there was a whole shelf. There was a whole shelf just dedicated to astronomical books. And I was in absolute heaven, um, because there were dozens and dozens and dozens and dozens of books now. Some of them getting pretty complicated, right? I look at them and I'd open them up and it's like, what? What? I don't get that. So gobbled those up pretty quickly too, and discovered probably maybe when I was 15 or 16 or so, I discovered the library at the local university, and the, the library there had pretty much a whole row of just books on like astronomy and physics. So sort of those two subjects were like this whole row. There were hundreds, hundreds of books uh, just on astronomy and physics. Not even math, not even any of the sciences at all. It was just sort of those two topics combined into one. And so by the time I got, by the time I found the university library, uh, that that was a lot. That was a lot. But then, but then I actually went to a university. It was a different one. I just went to the local university to find this library. But when I went to the university library that I ended up studying at, um, that was more or less an entire building. It was the science, um, science and engineering building. So that was a whole building, just a separate, dedicated building to science, and that blew me away. Section. There's a whole section of shelves just astronomy. So I was set. I was definitely set. That was very, very awesome. And yeah, all that's there still. But to have to go to the library and try to find things and all that, that's you know, definitely not impossible, but it's a challenge. It's a challenge for sure. And let's see, what am I doing here? I want to go there. I'm trying to get on the chat, is what I'm trying to do. Slowly but surely. Slowly but surely. There it is. So the internet today is definitely a lot easier to find things out. It's I don't necessarily think it's any better, but it's certainly uh, it can be a pretty good shortcut to finding out things. I'm just popping the chat out now. There's Uncle Bill in the chat. I saw him there for a second. I did. I did. Ninja Lurk. Hey, hey, hey. Hey there, Tom. Hope everything's well. Just talking about my experience with the trying to find out pieces of information, like as a kid, and how I first found sort of the local library, the little one, is like a bookstore, right? Just a um, few books in it. Probably had about a dozen books on astronomy, all for all for basically kids. So at the time, I consumed those great. Then I discovered the main library downtown, and that had uh, like like several shelves of just astronomy books, and that just blew me away. That kept me well fed for at least a few years, or so. Then I discovered that there was a library at the local university, and so I took a bus out there. I ended up going out there probably twice a month or so on the weekends, and uh, they had maybe roughly 2 or 3 shelves of just astronomy books, of all kinds, right? From the basic stuff up through uh, um, all the pro stuff. I think that's where I got my first taste of like the professional journals. Was there? I um, I remember reading Physics Today and looking at all the jobs and being like, man, that that one would be really awesome. And then I look at the next one, it's like, oh man, that one would be really awesome. And then I look at the next one, it's like, oh my God, that would be totally awesome. So yeah, I had a lot of exciting times there, sort of discovering the field. And I'm really glad that I found all that stuff really early, because I could sort of get over all the newness of it. I sort of discovered, I think, the university library out there probably when I was like 13 or 14 or so. So I had a good 4 or 5 years uh, of just trying to absorb as much as I could, and I certainly did. Had a great old time. So after the local university, uh, I moved. Of course, graduated, moved, uh, found myself at a larger university, um, where they have an entire building that is science and engineering. So it's like they had shelves and shelves and shelves and shelves of astronomy books, and it's great. It's just incredibly awesome to have access to all that information. And the interesting thing is that nowadays, right, there's even more information. Now, maybe you have to be a little bit more careful these days in terms of what kind of information you feed yourself. But the library is sort of the same way. It's a slightly different filter in that it's a little bit harder to find information that way. It's pretty easy to find all kinds of information on the internet, but some of it has some value and some of it doesn't. So cheers. This is dihydrogen oxide tonight. It's going to be an energetic night. I will get into that momentarily, hopefully. Cheers. I'm trying really hard to grow this audience, and I don't I'm not understanding why uh, why it's not happening. I mean, I could be a little more noisy, but I just don't want to be rude. I don't want to you know come across as sort of a pain, and it's like, oh my God, it's him again. But maybe that's what I have to do. I don't know. So guys, any ideas about how I can grow the circle of friends here? Because I'm interested in that. It's I love to talk astronomy, and when there's a crowd, I think that would be so much better. So I'm not really looking for a crowd for my benefit at all, although it definitely would. But I'm looking for a crowd to sort of benefit everybody. And that's why I'd like to get some panelists down here. So I mean, in chat, everybody can sort of talk over one another, and it's hard sometimes to follow chats. But if you have panelists down here, and I think I can have up to 10, right? If I can have some panelists down there, then we can actually have a back and forth conversation. and I think it'd be really, really neat. And you know, maybe I just need to be a little more active. Um, uh, there, yeah, I guess there are things that I can be doing, to be able to draw in a crowd. Uh, yeah, don't know. I mean, I'll be here every single night at the same time because the topic of astronomy, you can talk forever and never run out of things. So that isn't any kind of a problem at all. I'm just sort of looking for a larger crowd, to have conversations, you know, meander all I'm all over the place. I'm sort of mirroring this off of two live streams that I watch. One is Rick Beato, who I don't think he's doing a daily live stream anymore, but he does music, right? He's a musician, and he knows all the theory and all of that. And being a musician myself, I find it extremely interesting. Um, and but he draws in 150, 200 people, and so he's got this really interesting conversation that's going just over the chat, and I'm trying to figure out his secret. Maybe I'm just boring. I don't know, but I mean, I'm going to continue this because I think consistency uh, uh, can work for sure. That is one of the secrets. But you know, I I learned this long ago, and I I think it's very very true. You always hear that you have to be at the right place at the right time. Well, there's one more piece to that people don't seem to talk about much. Okay, and that is that you have to be prepared. Okay, so yes, okay, you have to be at the right place at the right time, but you also have to be ready for the opportunity. So, and I've experienced that many times, and so what I'm going, to continue doing is just staying consistent. And here, I will be consistent and I will be present, because at the right time and the right place, which is, don't exactly know when or where these kinds of opportunities just pop up. But if you're at the right place at the right time and you're prepared for the opportunity, then very interesting things can happen. And as I said, I would just like to have this circle of friends grow, so we can have some really interesting conversations, really you know interesting demonstrations, and maybe even talks, and all of that, right? And yeah, I think that would be very cool, very fun. But and as I said, I'm going to continue this, whether there are zero people watching or thousands. I don't really care because I like to talk about astronomy. Um, talk about the news of the day. Speaking of the news of the day, there's a rocket launch later tonight, and I was told that it's happening at 5:33 UTC, but I'm going to take a little bit of time here and see if I can gather some additional information about tonight's launch. Where are we going to go to do that? Um, well, we can just. I wonder if Twitter is saying anything about SpaceX. SpaceX. Let's find out. It's searching. Okay, according to SpaceX, okay, the SpaceX Twitter feed, uh, Hipposat 30W-6 are vertical on Space Launch Complex 40 at Cape Canaveral Air Force Station in Florida. Weather is 90% favorable for the 2-hour launch window, which opens at 12:33 a.m. Eastern Standard Time, 5:33 Coordinated Universal Time. So Coordinated Universal Time for me is I'm 7 hours behind Coordinated Universal Time. So if it's 5:33 UTC Coordinated Universal Time, I've got to subtract 7 from that. So if I subtract 5 from that, uh, that does that, and then I subtract 2 more hours, that's 10. So that's 10:33 p.m. local time, 10:33. So yeah, that should be a cool launch. It's always cool, still cool to see rocket launches. Definitely on my list of things that I would like to experience is an actual rocket launch. Don't know if I'll ever have the opportunity. Vandenberg is the closest to my location, but that's still, I don't know, 7, 8 hours away drive. So yeah, I don't know if that's in the cards or not because I'm not much of a traveler either. I'm pretty sure, as time goes by, I will definitely be able to see from my location, sort of the vapor trail from launches um, from Vandenberg. Uh, the one a couple of months ago that got everybody excited, I definitely would have um, been able to see that. But for some reason, I don't know why, I, I wasn't I wasn't paying any attention. I wasn't aware that there was a rocket launch, and it's just like what? So anyway, so I'm paying attention to these now for sure. I'm making sure that I'm paying attention to these things now. so yeah, tonight I guess it's at 5:33 UTC. So that's relatively late, but I'm probably going to be up at that time anyway because yeah, I wanted to there's one main correction that I wanted to make from last night's show, and that is the dynamic range that my camera has. It it has a 16-bit dynamic range, which is not 0 to 16,385. It is not. That's a dynamic range of 0 to 65535. So 65,536 um, uh, digital steps from min to max. So yeah, that even makes it all that much better. Because last night, I, for some reason, got it I got it into my head that um, that it was 16,384 uh, pieces, and no, it's 4 times that, so 64K. So yeah, I'm pretty I'm pretty excited about this possibility of satellite internet. I'm in a remote location, and my bandwidth is barely barely there at all. I'm amazed, that I can do this. So, but it turns out pretty well, nevertheless. But if I can get um, gigabit bandwidth, that would be very very awesome. It's gonna it might be a problem though, right? It might be a little bit of a problem if we're talking about essentially, doubling the number of satellites in the sky. Uh, you know how how much more I mean, if satellites are lit up uh, while moving through, you know, astronomical fields of view, and they're lit up by the sun, um, that has a lot of potential for damage. A lot of um, the astronomical um, instrumentation that's used is you know, can be turned up to pretty high gain, right? I mean, you know, if they're trying to measure something that's really faint, and you know, they turn the dials up, you know, to like 11, and then they're looking and they're looking, and all of a sudden, you know, a bright satellite flies through. That could fry electronics. That could fry electronics. So that's a problem. You sort of have the opposite problem too, is that when these objects are in shadow, they're going to be dark, and they're actually going to be blocking the light uh, from the object, you know, that you're studying. So yeah, I think we need to make an evaluation on how much of a detriment uh, doubling, you know, the number of satellites is actually going to be. And yeah, I hope that that's not going to be a problem, but it could very well be. That's a lot of dark objects up there. The You know, the saving point is, of course, that space is really big, and you know, the actual distance between satellites is usually pretty large, right? I mean, they always show the little uh, graphic showing, you know, all these white dots that are just sort of caked onto, you know, the surface of the Earth, and you know, that's sort of the those little white dots are not to scale. Okay, their positions, of course, are most likely correct, but their sizes are totally wrong. So it gives the appearance of a lot more stuff than what there actually is. Now there actually is all those satellites in there, but they're really small, um, invisible almost. But when you're an astronomer and you know you're trying to collect data, you definitely don't want some big bright thing zipping through your field of view, you know, potentially um, damaging instrumentation. You just don't want that at all. And as I said, on the other side of that, you don't want to be observing your target and have it vanish. Uh, so yeah, don't know. Still don't know how much of a problem that actually is. Maybe it isn't that much of a problem, but I'm sort of thinking that maybe it is. So yeah, that's. I heard that they had, you know, the fins and the landing legs on the first stage, but that they weren't going to recover them. Didn't hear why. So it looks like it's just bad weather out there. And yeah, I mean, if the weather's bad, you know, the platform is doing this, you can't land that thing. There's no way. There's no way. So they'll toss it. You know, they'll toss it into the water, and you know, just like every other rocket has has done in the past, except for SpaceX, um, we've gotten uh, sort of used to the landing now, where it's sort of like, what, you're throwing away the first stage? That's ridiculous. So that's an interesting and very rapid sort of change in thinking that I think is awesome. I think is awesome. Reusability is where it is, and you know, the space shuttle was a figment of science fiction, and it was just it was too complicated. They were trying to do too much sci-fi and not enough good engineering. What what I mean, they ended up sort of being forced into some really amazing engineering, because making that thing work, oh wow, what an amazing feat that was. But oh, so unnecessarily complicated. You know, I mean, rockets are complicated enough. Why make them any harder than what they already are? But we sure did. We made the shuttle intensely, insanely complicated, and it really is. It's a miracle that it worked at all. But you know, hats off to the engineers that worked those problems and solved it and did it very, very well, and only had what, a 2% failure rate on shuttle. That's still not acceptable when it comes to human lives, but statistically speaking, that's pretty much exactly what they predicted, was a 1 or 2% failure rate, and that's exactly what they got. Cheers. All right, well, cool. Hope everybody's doing well tonight. Big shout out to Dennis Hands. He runs a Periscope live stream, that's called, Let's Talk Astronomy. He does it every Monday. I want to say Monday morning. I've got it here actually. See if I can pull this up here. Dennis Hands. Okay. So he's on Periscope. You can just go, to Periscope, look him up, Dennis R. Hands, and he's on Mondays at 8 a.m. Eastern Time, United States. So that's 1500 UTC. And then he's on Wednesdays at 3 hours UTC, or 8 p.m. Eastern Time. So check him out. He was a teacher for 30 years, taught, I think, science and astronomy. Then he retired from that and is now teaching, I think, at a local college where he's been doing that for the past 11 years, teaching astronomy. So he's a very, very good teacher. Um, if you're just getting into astronomy, definitely check him out, because he knows his stuff. He knows his stuff, and he's a very, very good teacher. He usually formats his live stream in terms of like a little quiz, Q&A. So he'll have some questions, sort of not exactly trivia, but you know, name the four moons, the four Galilean moons of Jupiter, and then people will have to name them. But then that's a topic that he can talk about, right? He can talk about Jupiter. He can talk about those four moons, um, all kinds of things about them. So it's a really, really good show. Shout out to him, Dennis R. Hands, on Periscope, Mondays and Wednesdays, 8 a.m. Well, I'm just going to do 15 hours UTC on Mondays and 3 hours UTC on Wednesdays. So check him out for sure. I'm still trying to get a hold of him. He isn't responsive. For some reason. Um, and again, maybe I just need to be a little bit more aggressive. I don't know. I don't know. I don't think I'm that terrible, am I? I don't think so. Yeah. All right. Well, I think yeah. So that was one of the things that I wanted to correct from last night is that my dynamic range is actually 16 bits. So it goes. It's 65,536 discrete points I can sample. Uh, the other thing that I noticed is is that uh, I was talking about, how faint of a star I'm going to be able to image with my CCD camera. And what I determined is that I can get down to about magnitude 12 and a half with a 1 second exposure. So that's pretty awesome. But what I didn't realize, and that I just realized this afternoon, was that that's using a filter. That's using a red filter. I'm essentially cutting out 2/3 of the light, at least 2/3 of the light, if not more. Okay. So what I'm going to do tonight is I'm going to open it up, right? No filter at all. Just whatever light comes in, comes in. And if I'm right, if I'm right, I might be able to get another magnitude out of this thing with a 1 second exposure. I might be able to get down to less than 13th magnitude. And that would be extraordinary. That would be very awesome if I could do that. I'm sort of expecting to be able to do that. Yeah. So that's sort of tonight's task. Um, gonna, drag everything out. Not complaining at all because it's all I have to do is go right outside and it's pitch black. So, but yeah, I'm going to be basically looking at the same fields of view that I looked at a couple of nights ago, and that is M41, M47, M37, and then two just sort of random pieces of the sky. I'll just sort of randomly do it, and that will give me a pretty good sense of how faint I can actually see out here. I'm also not going to have any moon for a little while, um, but I am uh, obviously I want to start this after the end of astronomical twilight, and I was looking at this before for some other purposes, but I was seeing when astronomical twilight in my location starts. And oh, why don't I have that here anyway? Ah, there it is. So let's just see here. I'm just going to do it on my Linux screen, really quick like. Let's see. So March 2018, my location, astronomical twilight on the 5th starts at 7:42 p.m. So astronomical twilight for me just started, and it's going to go to 5:22 a.m. So yeah, right after this live stream, I can go out, set up, and know that I am that I'm past astronomical twilight, and that I'm in true darkness, which means that the sun is greater than 18 degrees below my horizon. That's sort of the definition of uh, the end of astronomical twilight. Cheers. Cheers to astronomical twilight. Let's see. Anything else going on? It's block three. Yeah. Yeah. That's what I heard. Is that yeah, I mean it's not a major loss. So, you got to do what the customer wants. That's number one, right? So, you know, if the customer is willing to pay, then you just do it. But we all know that has always been and will continue to be just a huge. I mean, it's just it's throwing your garbage in the ocean, and I drives me insane. It drives me totally insane. So let's try to recover those things. There's tonnage out there. There's tonnage, just lots and lots and lots of stuff. And in orbit, all those rocket bodies, those are all second stages, third stages that will eventually come back down. They'll burn up in the atmosphere, um, and 70% chance they'll splash into the ocean if there's anything left. And yeah, yeah, I think and that's why I don't call it a waste, because I actually think that that those uh, used rocket bodies might actually be an interesting habitat for life. So yeah, it's an interesting reuse of things, but still, it's basically just tossing our garbage into the ocean, which of course we already do. But it's like, yeah, mm, yeah, I think. I mean, it sort of looks like Block Five is the thing, and it looks like they're being pretty clean about it too. So yeah, it looks like that's going to be the workhorse for a while. Seems to work really really well. So yeah, but anyway, that'll be a fun launch. All launches are still extremely cool, and I'm just wondering, and I'm sort of not necessarily hoping for the day, but I'm anticipating. That's a better term. I'm anticipating the day where it's sort of like, oh, SpaceX launched and landed everything again. Okay, Blue Origin did the same thing. It's like, yeah, okay. I mean, I'm anticipating a time, and it's a different game for sure, but I'm anticipating a time where rocket launches will be about as exciting as um, jet planes taking off. Now, there's a big difference between those two things. So maybe that'll never really happen, because but at the same time, it's like when a plane crashes, you hear about it. Maybe not a small plane anymore, but the big planes. And when a big rocket explodes, you're going to hear about that too. So maybe you know I'm anticipating those two kinds of events becoming more or less equivalent, I guess is the right way to say it. So I don't I don't know if those will ever happen, because those are sort of different things. But mm, I'm anticipating that time. Don't know how long that's going to take. Don't know how long that's going to take. Um, Especially since like world launches, uh, world not rural world launches are becoming more and more um, frequent too. That's simply because there's more people, right? I mean, the United States comprises what, 4% of the population of the planet. So, I mean, it's just a numbers game, right? If there's more people available to launch rockets in place X, then you're going to see more um, rocket launches from place X. And I mean, we can only, I suppose, we here um, in the United States can only throw so many rockets up a day or a year, right? But a place like China, um, they have the potential of putting up two or three or four or five times that rate, just because there's more of them. That's all. There's just more people there. Um, so yeah, yeah. Lofstrom launch loops. Uncle Bill, I have no idea what a Lofstrom launch loop is. I'm gonna have to look that up. I don't think I've ever heard of a Lofstrom launch loop. Maybe you can expand on that a little bit while I take another swig. I want to do an object of the day, if at all possible. I can get that started here. I'll just have to Google it, find out what a Lofstrom launch loop is. It's very intriguing. Uncle Bill, you are full of intriguing information. All right, I'm going to share my screen. Let's okay, yeah, I will take a look at that. One of the things that nobody talks about, and I think it's potentially both a huge problem but also a huge benefit. That is the electrical potential between the ground and space is potentially, pun intended, uh, huge, huge. The and I should probably investigate this a little bit more you know before I sort of blast out everything. Um, but I think that there, as I said, I think there's a potential for not good and good. The not good is that if I think, at least if you don't take that into account, um, uh, you're going to have to deal with like these huge voltages and potentially very very large currents as well. But that can also be a benefit if you can somehow harness uh, that kind of energy. Then just having just moving through the air with this big long wire. You could potentially generate power. I don't know. It's an interesting thought. um, I mean, it's a fact that there is um, there is an electrical um, potential between like the ground and space. So yeah, yeah, space. Yeah, space elevator would have the same kind of thing. So yeah, I will check those out. I don't think at least I've never heard that term. Um, but yeah, you know we definitely need to uh, do something. The other thought that I had, instead of going out into space to protect ourselves from any kind of potential impact, there's also the possibility of going um, deeper into the planet, right? We haven't really uh, been anywhere past the crust of the Earth, which is already several miles thick. Um, I would think that, I mean, I guess it depends on the size of the asteroid, but even a relatively large asteroid couldn't penetrate, hundreds of miles down. Don't know. Would have to investigate that a little bit more. But the diameter uh, of our planet uh, is huge, right? It's 40,000 kilometers all the way around, divided by pi. Is that right? Yeah, so it's like 12,000, 13,000 kilometers in diameter. So that's what, 6,000, yeah, like 6,300 um, kilometer radius. And, I think that we've gone down maybe a few dozen miles, maybe a couple hundred, not quite sure. But I mean, even if we've gone down a couple hundred, right? Let's just say 200 miles, okay? That's 3% of the radius of the Earth. That's nothing. That's nothing. So, I think there's a lot of potential going into the Earth as well as going out of the Earth. So, maybe I'm changing my tune a little bit in terms of agreeing with Elon Musk totally about us having to be a multi-planet species just in order to, you know, uh, keep the species alive. Which I don't know if that's a necessary thing or not. But yeah. So let's do a quick object of the day. So I'm going to share my well. I'm gonna get my screen ready over here, and then I'm going to share my screen. Let's do a Messier. Let's do a Messier. So I'm going to share my screen. Here we go. To infinity and beyond. And let's go over to random.org and have random.org uh, choose a number. There are 110 Messier objects. So let's have random.org choose a random number between 1 and 110, and that'll be our object of the day. So here we go. Drum roll, please. Ooh, M109. M109. Now, I always like to pause at this point and see if I can remember what kind of object and where it is in the sky. And M109, I'm pretty sure, is another galaxy. But I don't know where it is. No, I can't say as I know where it is. So let's go to Simbad, is one of the many astronomical databases out there. And let's do a search for M109. Uncle Bill, you are out of resources. There's only one solution to being out of resources, and that is get more. That's all you can do, right? You have no choice. You have no choice in the matter. So you just need more resources. That's all. Yeah, so it is a galaxy. Okay, it's up in no, that's too high to be Virgo. So let's take a look here. It's characterized as a barred spiral. That's what the big B and the S stands for. S is for spiral, B is for barred. So you can see spiral means these spiral arms, and bar means this sort of straight feature right in the middle. Isn't that a beautiful galaxy? So what you're seeing there, right? This is a separate galaxy. This is outside of the Milky Way. So you're seeing, just a rough estimate like 500 billion stars. You're seeing like 500 billion stars. And you can see that it isn't quite face on. If it was face on, it would probably be quite round. So it's sort of set at an angle. You can sort of imagine um, galaxies, spiral galaxies at least, um, sort of being like flat plates. So they're really thin, but they're large and more or less round. So since this is not round, sort of elliptical shaped, that means that with that um, we are looking at this galaxy sort of at an angle, right? Hope that makes sense. We'll look at this picture a little bit more because it looks like it's in a cluster of galaxies. So these are on the equatorial coordinates. Right ascension is the first three numbers. So that's 11 hours, 57 minutes, 35.984 seconds. And then a declination of 53 degrees, 22 minutes, 28.27 seconds. So this is sort of like a longitude and a latitude up in the sky. If you sort of project our lines of longitude and latitude on the Earth and project them um, um, out into the sky, you sort of get the same coordinate system. So you can see that this galaxy looks like it's moving away from us at about 1,000 kilometers per second. So he's hustling along. And yeah, so he's 6.75 by 3.78 arc minutes. So that just means that this long axis here is about 6.75 arc minutes, and the shorter axis here is 3.78 arc minutes. And this position angle, at least according to this number at least, this angle here from north, so this is north, this is east. So this angle from north going east is 38 degrees. And yeah, that seems about right, because 45 is about halfway, and it looks about actually, really close to 45, sort of this side of 45. So here's all the magnitudes at different wavelengths. The ones that we can see are these B and R. So that's blue and red. And then we can also see U, G, and R. And you can sort of see that uh, at least in U, it's pretty faint. In B, it's getting pretty bright. That's like 11th magnitude. So that just means, the telescope like mine, which is a point, 0.2 meter diameter, I would definitely be able to see this galaxy with my scope for sure. Anything smaller than that, it's probably starting to get a little bit hard, but it is definitely not going to look like that, right? If anything, I'm just going to see, this brighter region in here. I might be able to discern a shape, maybe, but at least in my scope, because see, these magnitudes is the combined light of all of this. It's not just um, the brightness of like the center, right? It's the combined light. It's as if you added up all this light. That's what that number represents. So obviously, these areas here are much fainter than the central area. So probably, if I were to look at this through my scope, I would just see a little faint blob in here, just very small. Definitely would not be able to see by eye, the extent of this. Now, if I could take a long exposure, which is what this is a, some kind of a long exposure, minutes or hours, maybe, probably minutes long, then, I'd be able to see things like that. But just looking by eye, no, I'm going to see just, sort of the central area. We'll come back to this picture in a little bit. I'm going to sort of rush through this a little bit. So these are all the other names for this galaxy, M109. It's also NGC 3992. It's got an MCG number and a UGC number and a LIDA number, just lots and lots of different names. And basically, these are just different catalogs, right? They're looking at the sky either with a particular instrument, or there are certain um, characteristics that the galaxy has that they are sensitive to, and so it gets put into a catalog. And so there are all the catalogs. So 390 total um, references in the scientific journals. So that's a pretty active galaxy. Ooh, there's 6 distance measurements. Let's look and see how far away they measured these and see how consistent they are. Wow, that's quite a spread. Look at that. Here's a measured distance of 29 million parsecs and a measured distance of 18.37. So that's a difference of 11 million parsecs. Yeah, not very good precision there. Don't know about the accuracy because the precision is so bad. So we don't even know if we're close. But if you sort of look at the average of those 6 things there, I want to say it's about 25. So 25 million parsecs. So a parsec is 3.26 light years. 3.26. And we want to do a million of those. So that's 3.26. 3.26 times 10 to the 6th. And then we're going to multiply that by 25 because there's 25 million of those. So 25 of those. So that's 8.15 million light years away. So putting that another way, if I were to go out and observe this object tonight, which no, I'm not going to be able to see it tonight. It's in the wrong part of the sky. But if I were, and while I was looking at it, the light that I would be seeing from that star, and I have to correct this, it's 81.5 million light years away, 81.5. The light that I would be seeing from that tonight started from that galaxy 81.5 million years ago. So what were you doing 81.5 million years ago? I don't know. I wasn't looking at galaxies, I don't think. Maybe I was. The velocities look pretty consistent, right? They're all around 1,000 kilometers per second. So that's not bad. That's not bad. All right, let's look at the picture really quick. I am going over time a little bit here, and I do respect your time. I'm glad you're staying in, watching with, taking a look at this beautiful galaxy, M109, Messier 109. Let's zoom out here and see what's in the neighborhood. That's always fun to do. Yeah, so this, M109 is up around the Big Dipper now that I'm recalling it. In fact, I'm going to go, well, no, I'm not going to consult the charts. I think it's around the Big Dipper, if I remember right. So let's just zoom out a little bit more. And yeah, there are lots of galaxies in both the bowl of the Dipper and to its south. So it's next to a very, very bright star over here, obviously. Oh, no, I don't think this identifies stars. No, it doesn't. Okay. Well, let's move around a little bit more. You can see that there are some other galaxies here. these are probably, just judging from their sizes, and it looks like they're also spirals, they're probably in the background, right? So M109 is between us and these guys, probably. All the other, not everything here, but practically everything else here, all the stars, right, are in our own galaxy. And these are definitely foreground stars. So even these little things here, these are stars in our galaxy. But you can see that some of them, oh, I can't see any. I'm going to zoom out one more time just see if there's anything else interesting here. I think this is actually one of the stars in the Dipper, if I remember right. This was a relatively easy Messier object to find because of its proximity to this very, very bright star. Ooh, you can see a bunch of other galaxies down here. And ooh, look at that. There's even more. Oh, it's very exciting. Let's zoom in on one of them at least. Let's zoom in on that one. See what it looks like. Ka-chung, ka-chung, ka-chung. Oh, that's kind of a neat looking one. It's loading. Ooh, it's got a bar in it too. Look at that. Wow, and see how all the galaxies just pop out? Here's here's a spiral sort of on edge. There's an elliptical galaxy here. This is an elliptical galaxy. This might be a spiral, but maybe a really, really tight spiral. This guy, beautiful. Look at all these blue stars out here. Blue stars. There's a bar in the middle. So it sort of is looking like, it's hard to tell, but it's sort of looking like, maybe we're seeing this face on. Maybe. It is sort of elliptical this way. So maybe it's tilted a little bit. Oh, I don't know. Who knows? Who knows? So let's really, really, really rapidly look at some of the papers, and then I'll wrap this up for tonight. It's one of the awesome things about having a daily show is that like we can just do what we want. If we don't pack everything in, I don't feel as though I have to pack a lot of stuff in. This can be very casual, fun. Just talking astronomy, just, you know, turning off the TV, getting away from, the news for a while, thinking about cool things that we're passionate about. What drives galactic magnetism? Ooh, that's an interesting question. The way we measure, comparison of methods to derive radial surface brightness profiles. Uh, Frequency and stellar mass dependence of boxy slash peanut shaped bulges in barred galaxies. Mass models for 175 disk galaxies. Cool. This apparently is a very much studied galaxy. Unification of the fundamental plane and supermassive black hole masses. Yeehaw. Galaxy groups. So M109 obviously is associated with a group of galaxies or maybe a cluster of galaxies. I think it's part of the extended Virgo cluster, if I remember right. There's a lot of galaxies over there. There's hundreds and hundreds to see. Catalog of visually classified galaxies in the local universe. So 81.5 million miles is considered local. Molecular gas. That's cool. So they're looking at molecules in other galaxies. Pretty cool. Pretty cool. ARO has two facilities, one near me on Mount Graham and another sort of near me over on Cape Peak, and they look at submillimeter regions where where most of what they are um, looking at is molecules. Cold galaxies, huh? Cold galaxies. Well, there's over 200 of them here, so I am not going to go through this whole thing. I think for tonight, I'm going to end this. I'm going to, whoops, I meant to, whoops, I meant to do that. Stop sharing. Come back over here. Take one more gulp of this wonderful chemical, hydrogen or dihydrogen oxide. It's dihydrogen oxide tonight. Cheers. And I think I will call it a night. I'm going to get out under the sky. I'm going to drag this thing out along with all the computer and the wires and cables and everything else and collect some more data. Probably post uh, some of the images on my Discord server. You can see a link to that down below. If you haven't yet, make sure to subscribe, hit the thumbs up or the thumbs down, whatever you prefer. I'm interested in the absolute value of your reaction. And make sure to share this video. Talk about it. Tell people about it. Tell them that I'm here every single day talking astronomy. And I would really like a larger crowd. I like the crowd in here now, but if I can get a large crowd with the kind of people who are here now, that would be so awesome. That would be so incredibly awesome. So let me know, what you think I can do to grow this a little bit more. Um, uh, I'm here to talk astronomy, so that's what I'm going to do. But having a nice, sizable crowd in here, that would be that would be a lot of fun, and that's what a lot of this live stream is about. Is just having fun, sharing a passion for a little over an hour or so. And all right, I'm going to get out of here. I'm going to get out on the sky. I will see you again in a little less than 23 hours. 23. And all right, have a great day, a great night. And Astronomy Daily Live, we'll be back again tomorrow at 2 hours UTC. All right, peace out. Bye.